Hi, I'm Mike Elissen, and today I will show you how you can replicate the Ludum Dare infrastructure and build it yourself. In the past videos, I've explained the journey Ludum Dare has taken together with Akamai and what solutions they have put in place to build, deliver, and secure the Ludum Dare web application and API microservices. In this video, I will showcase how you could build this yourself through the use of Terraform, which interfaces directly with Akamai and Linode through their respective Terraform provider. Terraform is the industry-leading infrastructure as code tool to help codify and automate your online infrastructure. You can find this example on the Akamai GitHub. Inside of the folder, you will find Terraform modules to generate a PHP server with Linode, create an Akamai CDN configuration, as well as an Akamai security configuration. In order to replicate this, you will need an Akamai and Linode account, as well as valid API credentials to successfully authenticate your Terraform configuration to both the Akamai APIs and Linode APIs through using Terraform. Alright, with the proper authentication and API clients in place, let's move over to Visual Studio Code where we can create our infrastructure all together. First, we will create a Linode PHP server using the Linode Terraform provider. In the code here, you can see the reference to the Linode provider. We will also have to properly authenticate it, and here I'm using my Linode personal access token you can create in the Cloud Manager. Next, we have to specify that we're using the Linode provider, and I'm also passing the variable token for the personal access token. And here is the resource for the Linode instance that we're calling web. There are several parameters that we're passing in it, such as label, example-ludum-dare. We're specifying, very important, the image. This is the Linode Debian 11 Linux distribution that we want to use. We're specifying the region, the type of Linode, and of course we're passing on a root password that we can use to log into the server once this has been created. And the final two parts are advanced options that we're just leaving as is. And this should be everything that we need to create our Linode server using Terraform. In order to start, type in Terraform init. This will initialize the Terraform code, as well as look for the providers that you have. And this process should take several seconds to download the provider of your choosing. And here we can see Terraform has been successfully initialized. So we'll go to the next step in the flow, and that is Terraform plan. Terraform plan will actually verify the code and see what is the type of infrastructure that you want to create. And if there's no errors, it will show you through the resources that it wants to create a Linode instance that we have specified before. If everything looks good, you can move on to the next step, and that is Terraform apply. I'm adding the auto approve flag so you don't have to say a yes after the question. And here we go. Linode instance is now being created. This will send API requests typically to whichever provider that you have selected, and this should take 20 to 30 seconds or so and give you back the information that you're looking for, such as the Linode IP address and other settings. And there we go. The Linode PHP server has now been created, so let's take a look. If you look inside your terraform.tf state file, you will find the actual IP address that has been assigned to our Linode PHP server. You can see here the 212 IP address, which will be very important for us to remember. So we're going to copy this because we will be needing this IP address to tie into our Akamai CDN configuration. Now that we've created our Linode PHP server, we are going to use SSH to log into the machine. If you type in root at the IP address, you will be able to be greeted with a login screen, and this is where we will use that same password that we've created before. Now the first steps that we want to do is we're going to actually update the machine with using the apt update command. This will actually install the latest versions of Debian 11 and update certain packages. And we're also going to be running the apt dist upgrade command. It will also be updating several things. And with that, we now make sure that our Debian 11 instance is ready to go. So now what we're going to do is run the command apt install Apache 2, which will be installing a Apache server ready for us to go. And this should go very fast, and we will have a Apache server ready to go whenever we need it. So you can log out of the machine, and to check we can type in curl -i, and we're going to just make an HTTP request to the IP address, and there we go. We're getting a 200 OK returned, and you can see here it comes from an Apache server. So the machine is up and running and available. And you can actually verify this as well in your browser. So here you go to Google Chrome. You can see the Apache 2 Debian default page. And from here, you can go ahead and configure the machine as you want to, but at least we have handled the Linode part. We now have a origin server, a PHP server ready for us to go. But now let's add in the Akamai CDN configuration. On the Akamai GitHub, you will find a repository called examples Terraform, in which we have very helpful Akamai Terraform examples for you, including a Ludum Dare folder in which you can find this select use case. So go ahead and download the code and import it into whichever tool you want to use, but we're back inside of Visual Studio Code. There's a README file that will explain everything that you need to know, and throughout this video we'll go through the highlights of using this. So we will be creating a Akamai CDN configuration, also known as an Akamai property, and for that we're going to be creating a Terraform module. And you will see here that you have several host names and other settings to fill in. So we're going to be using the example ludumdare.akamaidevelopers.com hostname. We'll need an Akamai Edge hostname as well, which will route the traffic towards Akamai, and that is typically ending in .akamized.net. So we're going to be using that here. The origin hostname or origin IP address should be identical to the Linode origin PHP server that we've created, so we're adding in the IP address here. We'll need a CP code, your email address to get notified, and of course we're also going to be setting the same thing up for the Akamai Application Security configuration, so we can also secure our hostname as well. So similar here, you have to give it a name, a description, as well as the hostname. So we're just going to copy the same one, and in the bottom you have to add your email, and the rest of the settings you can just leave as is, but feel free to refer back to the README file for more information. So now that we've all set that up, we are going to be running through the actual Terraform workflow again. So we're going to run Terraform init to run through our Terraform code. It's going to initialize this, and it's going to find the Akamai Terraform provider and the latest version of it, and it will successfully initialize this. So next we're going to be running the Terraform apply command again with the auto approve, which will create our Akamai CDN configuration and our Akamai application security configuration for us. It'll go ahead and create all of this for us. All of these templates have been created using the Akamai best practices according to our consultants and our documentation. So it will generate all sorts of security settings for you, including also the performance and caching settings for you. So this process should take around a minute and a half or so, and it will generate everything for you and send it to the Akamai APIs for execution. All right, and after 2 minutes, everything has been created. All of the resources have been applied. We have our security setting up and running. We have our CDN configuration up and running. Now let's take a look and see if everything works. We'll be using curl again, so type in curl-i, and we're just making an HTTP request to the example ludumdare.akamaidevelopers.com, and you can see here it will give us a 200 OK, and it's actually deployed on our Akamai staging platform, so we see the Akamai staging header. And similarly, inside of Google Chrome, we can go to example ludumdare.akamaidevelopers.com, and now we will have that same Apache default page running on our Linode PHP server. So the requests are ending up at the Akamai server that interprets the Akamai security and CDN configurations, and that will forward that then to the Linode PHP server that we have configured in there. And with that, we have successfully created the Akamai and Linode infrastructure that is powering our web application and API microservices, mirroring the Ludum Dare use case. Thank you very much for watching the very first case study of Build, Deliver, and Secure with Akamai. I hope this was educational for you, and we hope to see you again with future episodes, or consider subscribing and catch up on some of our other video series here. Thank you very much, and see you next time. Thanks for watching Build, Deliver, and Secure with Akamai. We hope to see you again soon, so please consider subscribing to get notified on the latest videos. See you next time.